Okay, we're starting now. Welcome everyone to Cloud Data Driven Online User Group Meeting. Today's presentation is how to troubleshoot a slow running query in SQL Server and in Azure SQL. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years. I'm currently located in New Jersey, but I'm originally from Haiti. And I'm your host for today. The rules are you guys are free to comment, but do it with respect. There must be no offensive comments. I have your video turned off. And however, you do have access to unmute yourself if you guys have any questions. I have the chat disabled. So if you guys feel like you want to ask Amit any questions, just raise your hands. Also, please let's connect. Follow us at Cloud Data Driven on social media. We are on LinkedIn, YouTube, Facebook, and Twitter. Follow us, and then also visit our data community for latest update like Data Saturdays and SQL Saturdays. And we would like to say thanks to Git. I would highly suggest you guys to go and register for our first ever feature data-driven summit. We have a lot of amazing speakers for you. Please go ahead and register for yourself. We have that event here. This is the event, guys. I would highly suggest you to go and register. It will be a full day's event with different type of topics related to data and AI, DevOps, Power BI, and data visualization, integration, and automation, and cloud infrastructure. Okay, today's presentations, as I already mentioned, is how to troubleshoot a slow running query in SQL Server and Azure SQL. Our speaker is Amit Bansal. By the way, Amit, when I just migrated here, your YouTube, your articles, the kind of support you bring to the community helped me. And I just want you to know that. Amit, he's the founder of Data Platform Summit. He's a Microsoft MVP, and also he is a Microsoft Regional Director. Amit will introduce himself and give you more about himself. So we do have a tons of other presentations lined up. The next one is SQL Server Performance Tuning. And we have Hilary Carter. I would highly suggest you guys to go and register for that as well. The next one will be Crash Course on Azure Synapse Analytics for Power BI developers. And Nicola Illik is the one that will present that session to us. Please go ahead and register for that. And if you guys have any presentation you would like to present to us, feel free to email me at jean.joseph@bigdatadriven.org. Amit, it is an honor to have you here. The floor is all yours. Feel free to share your screen and start with your presentation. Thanks again. And thank you everyone for tuning in.
Thank you so much, Jane. Welcome, everybody. My name is Amit. I'm going to be your speaker for next 45 to 60 minutes. And yes, of course, Jane, the honor is mine, in fact, to be part of your community. And thanks for the opportunity to present this session, Troubleshooting Slow Running Queries in SQL Server. I would just share the screen in a moment. Okay, so if Jane can confirm, you can see the screen. All right. So yes, welcome once again. Right, welcome once again. So troubleshooting slow running queries in SQL Server and Azure SQL. That's really the full title. So thanks, Jane, again for this wonderful introduction, and thanks for the opportunity once again. And good morning, good evening, wherever you have joined from today. This is going to be a demo packed session. So they're going to be demos today where I will show you how you can troubleshoot a slow running query. My name is Amit Bansal, and there are a few links here. Jane will probably share them with you on an email, but you could search for SQL Maestro's YouTube channel. There are a lot of videos out there, and you can, there's a bit.ly link here, connect with AB if you wish to connect with me. I have been working with SQL Server for a couple of years now, and my focus area has been performance tuning. I am on Twitter, _Bansal. That's my Twitter handle. All the resources, including the scripts that I'm going to use today, you can find them on this bit.ly link. Or the simplest thing is to just go to sqlmaestros.com, and you will be able to explore all the videos, all the resources, everything that we have to offer, and it's all free for the community. Also take a note, recently we launched a SQL Server magazine for the SQL community, which is also free, and this is the link. You just have to go to bit.ly, https://SSG magazine, and SSG here stands for SQL Server Geeks. Right, friends, so that's the quick introduction. Now let's begin with the content. All of you are here for the content, and you would like to understand how we will troubleshoot a slow running query. Now, before I explain you how I would do it on SQL Server or Azure SQL, I first want to put this question to all of you. What would you typically do? If you see a query which is not performing well as per your expectation, which is the execution time is slow, there is slowness in the query, users are waiting, and you do not really know what's going on, and the query is taking from a few seconds to a few minutes to a few hours, what would you typically do? At this point, you can please unmute your mic, and if you have any answers, you can give me. I'm just wanting to understand, what would you do? What are the first few things you would like to do when you see that a query is running slow? And feel free, any answer is appreciated.
You guys do have access to unmute yourself. Feel free to do that.
Okay, yes. So all of you can, so yeah, not all of you together, but some of you can unmute and let me know. Let's.
Okay, normally I will run an executed execution plan. An estimated execution plan. Yeah.
Okay, perfect. So that's a good response. So we will check the execution plan. Great, very good response. What else? What else comes to your mind apart from execution plan? Anybody else?
Hi, Amit.
Yeah.
So we can look at the execution plan, and can check whether the existing indexes are being used, and also
Okay.
look at the cost of each of the component where it is getting hit.
Okay, perfect. So there's another option there, looking at indexes. So if we look at the broad category, yeah, go ahead,
You also
John.
want to check CPU pressure. You want to check memory pressure, check the environment.
Okay. Okay, so we have check resources, which is CPU pressure and memory pressure. So if the query is running slow, we would immediately go and check for the resources on the server, CPU and memory pressure. So we have three answers here. We have the execution plan, look at the indexes, look at server resources, maybe CPU, memory, and IO, all three of them. What else? Anything else comes to your mind?
Maybe issue with blocking deadline.
Okay. Okay, so blocking, let's go and look into concurrency. If we could probably see if this query that is running slow is probably blocked by another session maybe. So that's the fourth response. So we got four answers. Anything else that comes to your mind?
We can also look at bad joins. Maybe we're joining incorrectly with the wrong foreign key.
All right, so Paul has something to do with joins. So look at probably joins. I mean, are we joining the right way? Maybe Paul, you're hinting at joining maybe without any predicates. So which could be a long, loop of joining large data, which is slowing down the execution, maybe.
Appropriate index not used.
Okay, so we covered that. Great. Again, indexes. What else?
nested selects.
Fragmentation issue.
Fragmentation, nested select, a lot of stuff. Why
Stat-
is anybody not
statistics,
talking about weight statistics?
statics not updated.
Okay, stats not updated. Fair enough. No one is talking about weight types here. Okay, how many of you do not know about weight types and weight statistics? That kind of feature in SQL Server, that concept and that architecture of weights. Raise your hand. You could just raise your hand. That will be a good indication that, okay, you have probably heard about it but never used it. Something like that. Or maybe you just kind of read or heard but have never got an opportunity to work in depth with what weight types or weight stats are. If you are one of those, please raise your hand and I'll get some indication as to where you stand with weight types and stats. Okay, I can see a few responses there. Many of you are raising your hands. Okay. And I guess so because none of you really talked about weight types or weight stats. In fact, I got all the answers that I was probably expecting. You talked about execution plan, you talked about indexes, you talked about blocking, you talked about CPU and memory resources, statistics, and so many things, but you did not mention about weight stats. And let's, okay, great. Thank you so much for the responses. Now let's jump back to the presentation. So, these are the things that you would typically do, and look at these options here. This is of course not a comprehensive list, but probably some of you talked about these things, isn't it? You talked about update stats, execution plans, locking and blocking, indexes, look at IO, CPU, memory, check your T-SQL code. Are there improvement opportunities in the T-SQL code? Use the different tools like Profiler, etc. Activity monitor, and that's what someone talked about, right? Resource usage, CPU and memory, and then maybe even look at perfmon counters. But then my starting point when I am troubleshooting a slow running query would be to go and check weights, weight type and weight statistics. Now, when we talk about troubleshooting slow running queries or troubleshooting query performance overall in any database for that matter, it is really an art. And today, things that I am going to show you, it's remember, it comes more out of experience rather than following a textbook. There are no predefined rules or guidelines that this is exactly what you have to do. Of course, there is some science behind it. There is a scientific approach, but then there is also a lot of art to it. So you know how things work inside SQL Server. That's the first knowledge we need to know, is what happens inside SQL Server. How is the query being executed? What is the life cycle of the query? That's the science part of it, because that is something which you cannot change. But then during its course of execution, the query itself, what can you do? How can you go inside SQL Server and look at a lot of different things that are available at your disposal? That's probably the art of it. So given 20 different options, you may pick up a few of them. And as I said, there is no really guideline or rule book to it. It's just like what really works for you. Now, I know that so many of you who have given answers like stats or execution plans or locking, blocking, indexes, you're giving these options because in the past, probably these things worked for you. Maybe when a query was running slow, you went and looked at indexes and you redesigned your indexes and the query performance improved. So you know, okay, indexes works. So that comes to you top of your mind. Maybe you looked into the execution plan and you figured out a problematic area, you rewrote your T-SQL code and you fixed that. So that is on top of your mind. So really things work because that's what your experience has been. So today, what I am going to show you comes out of a methodology, a kind of a methodology that works in most cases, but then there is no rule book that this is how you have to go and there are no other routes or there are no other options. Don't take it like that. Think about methodology. Now, here is a slide in front of you where I would talk about weight types and weights inside SQL Server. So the logic is simple, and I'm going to give you a very simplified overview. On the top left corner, you can see the database, and those red arrows represent incoming queries, incoming workloads, and they are being processed by the database engine, by SQL Server. Now, what happens is in a query lifecycle, from the moment you click on in Management Studio, execute, or the user fires the report or the stored procedure from the client application, the moment the request is received by SQL Server, the life cycle of the query begins. Life cycle of the query, and the query life cycle completes until the last byte of data is served on the client. And from the beginning of this life cycle till the end of the life of the query, a lot of things happen inside SQL Server. I can spend a whole day talking about what will happen inside SQL Server, but then of course, and maybe someone in the community or someone in Microsoft can spend a whole month talking about what happens with the query lifecycle from start to finish. But in this 1 hour, out of which now 45 minutes are left, like what can I talk about? I can talk about the weights. Amongst many things that happen inside SQL Server, one of the things is your query needs resources, right? Your query that is hitting SQL Server needs resources to run. What kind of resources? It needs CPU, it needs memory, it needs IO. I would request everybody to mute, please. So it needs these resources. Now, we talked about CPU, memory, IO, but then the world does not end here. More resources are required. For example, your query wants to read data from the disk. You know, data in SQL Server is stored in pages, and those pages might be on disk. So your query needs access to those pages. So that page is also a resource. Now, your query might have sorting. Your query might do complex aggregations. So you need extra memory to perform those. So those are also termed as resources. Now, your query might want to run in parallel, right? It might be a complex query, and the optimizer decides that I'm going to assign multiple threads to it. So your query has to run in parallel, which means it needs more threads. Threads is also a resource. Now, when SQL Server, your query inside SQL Server needs these resources, SQL Server will record that information. And if your query has to wait for any of these resources, SQL Server is recording that information. In hindsight, if you see when a query is being fired inside SQL Server, plain speaking, look at a very high level overview, right? Either the query is running, right? It is running, it is doing its job, or it's waiting. Either it is running, it's doing its job, or it is waiting. And it is waiting for what? It is waiting for resources. Maybe your server is short on CPU. Maybe your server does not have enough memory. Maybe the IO is choked already by a lot of different workloads that are running, and your query is not getting enough IO ports. Maybe the data that your query needs is already logged by another session. Maybe there is an exclusive lock already on that specific table, or on that specific row, or on that specific page. So your query is again waiting. Someone talked about locking and blocking. So maybe your query is blocked. Why is it blocked? Because it's waiting for a resource. So SQL Server is recording what your query is waiting for. If you are able to find out, what your query is waiting for, you get one step closer to troubleshooting the slowness of the query. This is the most critical thing we need to understand out of this session. If you can find out what is your query waiting for, you get one step closer in troubleshooting the slowness of your query. Now, the question is, okay, where is that information being recorded, and how can you access that? So let's understand that. All of you know that SQL Server exposes many DMVs, dynamic management views, like sysdm OS wait stats, sysdm OS waiting tasks, sysdm exec session wait. So I've put some of them here. There are close to 300 dynamic management views. Not all of them are really required in day-to-day troubleshooting, but these are the important ones. So let's first understand that which DMV will give you what kind of information. When SQL Server is recording that information, now your job is to find out where is that information recorded, how can you extract, how can you interpret it, and how can you use it to your advantage to find out what is your query waiting on. First one, the first DMV right on the top, sysdm OS wait stats. This is a DMV. Look at the name, Dynamic Management View, DM. OS stands for SQL OS, wait stats. It has the statistics. It has the overall cumulative statistics of all the different wait types. Now, I use this word wait type. You need to understand that every time your query is waiting inside SQL Server for a specific resource or whatever it is waiting for, a wait type is being assigned to it, right? Wait type, that's called as wait type. And when it is waiting for, let's say 10 seconds, that is called as wait time. Now let's take a real metaphor. Excluding this year and the previous year of pandemic, when you were regularly going to office, right? You get down from your apartment, maybe you're using the elevator. Then when you get down from the apartment, you are probably waiting for a public transport. Let's say if you're using a public transport, then you reach the office and you're again waiting for an elevator, let's say. So look at a real life metaphor, right? Each day we encounter waits every day in our life. Either we are waiting for elevator, we are waiting for public transport, we are going to our office cafeteria and we are waiting in the queue. This is an important thing, waiting in the queue for your token to be served by the counter. And there are people already standing in front of the queue because they came into the queue first, which is first in, first out. This is exactly what happens inside SQL Server, which is when your query is waiting for something, maybe elevator, maybe transportation, maybe cafeteria. These are different wait types. Depending on what they're waiting for, a wait type is assigned, and there is a queue because for that specific resource, it's just not your query. There could be other queries also that could be waiting for the same resource, and they are ahead of you in the queue. And that is why we call this concept as waiting and queuing. Now, this is all conceptual. The moment I go into the demos, all of that is going to be clear. So let's go and now talk to SQL Server and extract this information. When so many workloads, friends, when so many workloads come and wait for all these different types of resources, this is all aggregated. This is all aggregated and summed up, and it is in sys.dmos wait stats. So sys.dmos wait stats will give you aggregated cumulative information of all the wait type and the total sum of each wait type. That is what you're going to get. So mind you, you are not going to get individual query wait information from sysdmos wait stats. It's going to give you instance, your SQL instance specific information. Now the question is, hey Amit, that gives me total cumulative instance specific. How can I get information about only my query? Well, this is the second DMV, DMOS waiting tasks. DMOS waiting task will give you real-time information about your session, your request, what it is waiting for, and how long it has been waiting for. So this is the most critical DMV for real-time production troubleshooting. SysDMOS wait stats, the first one, is good for reactive analysis. After your query has ran and it caused a lot of problems, blah, 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 and you're troubleshooting later in the day as to what went wrong and you want to look at an overall picture, then that DMV is useful. But when you want to do real-time firefighting and production troubleshooting, that is DMOS waiting tasks. Now, these are the two DMVs, but there's one more DMV, which is dim exec session waits. This will also give you real-time wait information about that specific session. Let's say, and when I say session, you understand, right? We're talking about SPID, S-P-I-D. Every session has a number, right? 62, 75, 92, 105, whatever. So for that specific session, what has been the total wait, etc., you will get it from sysdm exec session wait. Now, not only the DMVs, the good thing is SQL Server is also giving you a lot of information about wait stats and wait type in the execution plan. And I think starting from SQL Server 2016, if I remember correctly, execution plans will also give you that kind of information. If you right click on the select operator, which is the first operator in the execution plan, go to properties, you will find some information there. Now, let's understand one thing. Okay, when your query is running slow, you have all of these DMVs and you're writing your queries, you're running your scripts, and you're finding out. But let's say one fine day you are not in the office, right? You are the main DBA and you're not in the office, and you want to capture wait information even while you are not in office, even while all those slow workloads are running, and you want to capture the information passively, right? Silently, you want to capture all that information and analyze it later. Then your answer is extended events. Look at the right bottom in the middle, extended events. Extended events, in case you do not know, is very similar to Profiler, and it has an event called wait info. So you could set up a trace. Trace is not the right word for extended events, but anyway, you could set up a session in extended events and choose wait info event type and put certain filters like session ID, database, and username and whatnot, and capture wait information. This is very, very powerful tool to understand where is your query running slow. Now with this information, let's go and jump over to a demo. First, let's see a demo, and then I will take up questions. So let me see if the screen share is working. Just a second. Okay, so someone can just confirm, Jane maybe can confirm if my VM is visible, and I've just launched a SQL file. Management Studio should open up now.
Yes, sir, I can see.
Okay. So friends, in this demo, I'm not rushing through a lot of examples. I am ensuring that the core concept about wait types are clear to you. I would probably just show you one demo, and that one demo hopefully will be very, very impactful in you understanding what wait types are and how to find them out, etc. And looks like Management Studio is not behaving very well. Okay, yes, now it's behaving. So let's get started. And I would strongly recommend that you may want to probably practice some of these scripts. So what I am doing is, and of course, as Jane will share the links with you. So I'm actually getting into working with wait stats. That's the folder, and I have a few scripts here. Let me just open all of them, and then I will explain you what I am trying to do. Okay, let's get started now. So I have opened file number 1, 2, and 3. First file says wait stats analysis. The second one talks about monitoring the waiting task. Third one is blocked query. Okay, so let's do this. Wait stats analysis, monitoring. Okay, so in blocked query here, in first window, I'm going to begin a transaction. Let's create a new window. So let's copy this, put it in a new window. In window 1, which is I'm simulating as a user. I use AdventureWorks 2016, and I'm running a transaction. I begin a transaction, and I'm updating a table called person.person. I'm setting last name equals to Bansal, where business entity ID is equal to 1. Now note that this is an in-flight transaction. I begin the transaction, but I'm not rolling back and I'm not committing, which means all of you know that when I'm doing this update, a lock is going to be held. An exclusive lock will be held on that specific row in the table. So let's do that. And I am executing this. Now, one row affected, the lock is still there and the transaction is still active. Now, in the second window, let's assume that this is the second user. In this second user, I am firing a select statement and I execute this. And now this query is running slow. Now you might be surprised. I'm saying this query is running slow. Of course, this is running slow. It's not giving me the output, and it's been a few seconds. But now you all know why it's running slow, because I showed it to you. I showed it to you that one of the user is already holding an exclusive lock, and this particular user wants a shared lock on the same resource, and it is running slow. But remember what it is doing. It is actually waiting. It is waiting for a resource. What is that resource? The resource is lock. It wants to acquire a shared lock. And because it's waiting to acquire a shared lock, it's not able to give you the output. Now let's talk about troubleshooting, right? Now this is the basic premise. Whenever a query is not running in the so-called expected time frame, there are chances and possibilities that it is waiting on resources. Now let's jump over to the second script here, monitoring. Now, first thing what we are going to do is I'm going to clear the weights. I won't clear the wait sets right now. My session is session ID 53, which is waiting. So what I will do is I'm going to show you all the DMVs, but first I will show you the most important DMV, as I told, dim DSOS waiting task, which will give me real-time information. So I'm going to say 53, and let's go and fire this and see what's happening. Now you get this information that session ID 53, this is our session ID 53, which is actually waiting. Note this one. 53 is waiting, and it has been waiting for more than 93 seconds. If you keep running this, keep an eye on wait duration. I execute this again. Look at the number is constantly increasing, 114 seconds, now 116 seconds, 117. So this is constantly increasing. This is what we call as wait time. Here it's called as wait duration, but if you go to the stats DMV, this will be wait time. And this is your actual resource wait type, LCKMS. Now each wait type has a name inside SQL Server, and this is called as lock mode shared, which means your query is actually waiting for. I would request all the attendees to be muted, please. I think the puppy is barking because it's waiting on lock mode shared. Anyway, so no one likes to wait, right? Not even our pets. So we have this wait type LCKMS. So this query is waiting on this specific resource. And didn't I tell you that SQL Server has all these different wait types, right? So let's now take this DMV, okay, and first put it in a new window here. And this is the cumulative one that we talked about. So if I do a select star from wait stats, you will see all the different wait types here. Look at this. So there are, oh wow, in SQL Server 2019, you have more than 1,000 different wait types. Now, no one on earth really knows what these 1,000 wait types really mean, with so many of them as preemptive, which is focused on Windows. But we focus on the common ones. There's so many that are sleeping in nature, that are queues in nature, but we focus on the important one. Now, what I want to do here is filter on wait type LCKMS, because this is the problematic ones. And if I and yeah, let me also show you. Let me first filter on this. Now you can see wait time MS, wait time in milliseconds, and you can see it is 118. Now this is going to surprise you, because here if you see, oops, too many. Okay, here if you see the number is quite high, 119, and if you look at the wait stats, oops, if you see here it is 118. So your question could be, why is it showing me such a low value? Simply because the wait is still going on. The wait is still not completed. Only when the wait completes will you be able to see that value being added up here. And also remember what I talked about wait stats. This is cumulative, which means if at this point, if there were 5 workloads that were running, and if let's say all of them were waiting on LCKMS, all their wait time would get added up, and you will be able to see this here as a cumulative value. So this DMV is really good if you want to troubleshoot general slowness in SQL Server, instance specific. You want to find out where are there problematic areas. Is blocking a big problem? Because if blocking concurrency is a huge problem, you will see huge wait time adding up here. So that helps you in general slowness. But if you want to troubleshoot on real-time basis, as I talked about, then we are going to look at waiting task. Now let's run this once more and see the number has gone really up, 309 seconds. Now, what are the other things that waiting task tells us? Specifically for blocking, it also tells me that my blocking session ID is 56. And that's true. This is the one where I ran the transaction. Oops, sorry. And this is the one that I ran, 56, right, where we ran the updated statement. All right, friends, now let's do one thing. Let's complete the wait, which is I am going to go back to my update statement here and let's call rollback. Now, when I call rollback, if you go and look into this query, it runs and it fetches all the data for you, right? You get the output. Now let's go back and look into the waiting task first. Is session ID 53 now waiting for anything? Let's go and execute. No, it's not waiting for anything at all because the execution is complete. The wait is over. You have got the output. There's no active request. There's no active task from that session ID 53. So of course you get a blank result. Now the most interesting thing, when we ran this one, we were getting 118, but now the total wait time for that specific session will get added up here. So let's go and execute. Look at the number there, 358 seconds is what the query waited for. The moot point that we need to understand here is wait types, and analyzing wait types and recording and capturing this information brings me closer to troubleshooting why the query is running slow. Now let's do this a second time once more, and let's look at a few more things. So I would run this one again, and now I will do a select again. But before I fire the select statement, I'm going to turn on the actual execution plan and execute. And now we're waiting again. Now, if you still look at session 53, and again it's waiting, and this time let's just wait for a few seconds. Let's say 10 seconds. So we waited for more than 10 seconds. Let's go and execute a rollback. And you get the output. So I talked about there are different other ways from where you can get wait information. So let's jump over to the execution plan and select the select operator, right click, go to properties, and you can extract wait stats here. And you can clearly see that there were two waits that were encountered. And what's important to you is LCKMS here. Starting from SQL Server 2016, this information is available. In case you're trying to do this in earlier versions of SQL, like 14 and 12, in properties window, you will not have that information. And you can see we waited for 16 seconds. So that's another way on how you can extract wait information. We also talked about a DMV called, let me see if I have this here. Okay, select star from sys.dm underscore exec underscore session wait stats. Let's do this and filter on where session ID is equal to, and the problematic session was 53. What do we get? Let's look around. And there you go. Look at this one. So this is interesting because for your session 53, since its lifetime, the moment we kick-started session 53 till now, till I run this query, what has it been waiting for? And you can see LCKMS right on the top with wait time MS. And this is also temporary, which is if session ID 53 closes, then this information will be lost. So this information also gives you wait information. So there are a lot of different ways on how you can capture wait information and get closer to troubleshooting why the query is running slow. All right, now let's pause here for a moment. I have about 20 minutes. So I wish to take up some questions. So why not raise your hand, and then if we can lower all the hands for the time being. Okay, let's lower all the hands, and then we can, I mean, maybe Jean can help in unmuting one by one and can call out the person who wants to ask questions. I'm sure you will have many questions now at this point.
Okay, Amanaf, you wanna go ahead?
Yes, let's start from top to bottom. Amarnath, go ahead and unmute yourself and you can ask your question. Okay, so let's move on to the next one.
SK?
SK, yes. Do you have a question? Okay, Subha Reddy, your turn now. You can unmute yourself and ask a question.
No questions.
Okay, perfect, Subha. Thanks so much.
I need more information about this weight types. What is LCK underscore M underscore C? Yes, what is expected?
Okay, so yes, the weight types that you see in the list, there are so many of them, and they have, some of them have abbreviations like LCKMS. It stands for lock mode shared. LCK is lock, M is mode, and S stands for shared. What does that mean? Our select query was asking for a shared lock, and it had to wait. Because when in SQL Server you want to read data, you need shared lock on the resource. And because our query had to wait to acquire the shared lock, the wait type is lock mode shared, and thereby LCKMS. That's the abbreviation. Thanks.
Thank you.
Yes. Patel, Mr. Patel. Oh, sorry, Trupti. Any question there? Sridhar, any question?
So you can hear me, right?
Yes, Sridhar, please go
All
ahead
right.
with your
Yeah.
question.
So the all this, the queries you have said, like, is there any difference for Azure SQL?
Okay, great question. No, I guess most of the DMVs that I showed you would work exactly that way in Azure SQL also.
Okay. Yeah. Thanks.
Thanks, Sridhar. Okay, next it's Hanu's turn.
Yeah, I'm having a doubt. Like, for example, we have a blocking, right? And we used to kill the root blocker. But when can we decide? So I don't want to kill anything. So when can we decide how long it will take to complete this transaction? Sometimes the blockings automatically, are completed, right? And what basis it
Yes.
will be completed?
So Hanu, this is very difficult to predict that when a blocking situation will be over. I know it's a common practice to kill the lead blocker. One session could block multiple sessions. Now, very difficult to predict what business logic is going on at that point in time. And killing the lead blocker might have more repercussions, which is if it was a long running transaction, rollback can take a lot of time, and incomplete transactions, all the ones that we're waiting will probably one after the other go through, but there is no guarantee that they will again be encountered in the wait. So unfortunately, it is very difficult to answer this question and very difficult to predict when the lead blocker will actually be done. I mean, someone like you can only answer that because you know the environment you are working in, you know the application and behavior and the querying pattern behavior, etc. But otherwise, no one would have that answer. Yeah.
Yeah, I understand. But is there any way we can check the query apart from the percentage? So it's completed or something like store procedure or function.
No, there's no way. There's no way to check that, right? What logic is running inside the stored procedure, how long it's going to take. The only way is to go and understand what the logic of that stored procedure is, for example, what kind of operation it is doing, and what is the execution history of that stored procedure. So your stored procedure has business logic inside it, and you know the past execution times of that stored procedure, right? Which could be in a baseline. For example, that stored procedure generally completes in 5 seconds or 10 seconds. You know that behavior. So what you could probably do is find out what it is waiting for and then take your call accordingly, right? And like the technique that I showed you can work exactly this way in your case to find out what it is waiting for.
Okay, thank you very much.
Yes.
So can I ask one more question? So if I have chance,
we'll move on to the next one, then I'll come back to you again. Yeah.
Okay.
So those for those of you, the question is answered. If you can please lower your hand. I'll move to J. JH, you have a question?
Yes.
Please.
As we said in the previous question, if there is a stored procedure, so what type of lock will be there? I mean, what will be the wait type? If it has
the
no
wait
transactions in the procedure, if it's a report.
So Jay, there could be any type of wait inside a stored procedure. We cannot say that. I mean, your stored procedure, as I saw, there should be a blocking scenario. But let's jump over to another example. Can you all see the screen? And let's look at this example where I'm talking about page IO latch wait type, right? And let's jump over here. Let me clear the wait stats. This is how you clear the wait stats. And let's look at this output now. So you can see right now, all of you can see that I'm filtering on page IO latch. This is another wait type. Look at the numbers. These are all zeros right now. And no session is right now waiting on page IO latch. But if I just fire a workload, let's say I had about 100 users and jump over here and execute this again, look at the numbers now. Let's close this workload. And now you can see so many threads are waiting on page IO latch. So I'm just trying to show you examples that there could be so many different types of wait type. We do not know what SQL Server inside SQL Server your query could be waiting on. In a moment of a second, you can see so many tasks. 24,000 wait occurrences of page IO latch has occurred, and this is the total cumulative time. And these are the details of each session. Look at the session IDs out there, right? So it is very difficult to predict. We do not know, but we just have to understand from the querying pattern, or you might have to troubleshoot, which is capture that information using extended events.
Any such common wait types that are frequent?
Yes, exactly. Yes, Jay, that's the right thing. Are there common wait types? Yes, there are. Common wait types are CX packet, page IO latch, page latch, resource semaphore. Thread pool is not so common, but then yeah, could be considered as common. And then of course, all these wait types related to locking and blocking. These are some of the common wait types that keep occurring all the time.
Sorry to interrupt. What is page IO latch?
Page IO latch stands for page IO latch, which is your query waiting on the disk to fetch the data from disk into memory. So this is reading the buffer from disk into memory. This is the wait for that.
Okay, what is latch?
We use the word latch here because SQL Server, when you fire a select query, the query wants to fetch the 8K page from disk into memory. Why does it want to fetch? Because it wants to read. But before it will read, it will apply a latch on the page. Latching is an in-memory technique to protect the physical integrity of the page. That's why we call this as a latching mechanism inside SQL Server. That's why the term latch.
Okay, thank you.
Yes. So Jay's question is answered. Subha Reddy's question is again. I'm coming back to Trupti again. If there's any question, Sridhar, any more questions, friends? You can unmute yourself.
Amit, can you hear me?
Yes, Anu, please.
This is Rajiv.
Okay, Rajiv, tell. Yes.
So are there scenarios, I don't know whether, because I joined a little bit late, are there scenarios where there are like, runaway processes just kind of holding on to some latch or lock, and they are just like zombies? And how to identify them? And or does SQL Server automatically clean those up after a particular time?
No, Rajiv, SQL Server will not automatically do anything at all because these are all user-specific sessions. If they are simply throwaway queries, long-running queries, and as you term them as zombies, you are the one who has to identify them. SQL Server has no way to figure out who are zombies and who are humans.
No, so let's say if there is no like, is there a like concept of like a terminal that, okay, so long as there is a kind of a, like attached OS bit or something like, which is like a physical existence, then SQL Server say, yeah, this is alive. And then if it's not, then okay, it's a clear-cut case of this process is just hanging in there like leftover, thing. Is there anything of those lines?
No, Rajiv. That kind of concept does not exist in SQL Server. I think you're referring to as kind of an orphan session or something. Something is just running but does not have a SPID attached to it. No.
I mean, as a leftover, let's say somebody was running something and then their session encountered a hiccup, boom, but that cleanup,
no.
Okay, there is nothing of those. Okay.
There is nothing of that sort. If there's anything like that happens, it's a bug, should be reported to Microsoft. So that's technically cannot happen.
Okay, thank you.
Yes, friends. So more questions?
Yeah, hey Amit, this is Trupti. Sorry, I know you asked a couple of times. So we are noticing that we have multiple SSIS running like every minute. In some strange reasons, those after finishing the execution, those sessions are not getting cleared. So is there something we can see somehow?
No, how do you know, Trupti, that after executing those sessions are not getting cleared? How do you find that out?
So when we look at the monitor window, we do try to see how many sessions are still open under that ID, that specific ID, and it still shows that those sessions are still on.
Okay, so
you're it's actually trying to connect to another database, and another database side, we do see those connections are still active.
Okay, which means you're actually trying to refer to from the application side. Application is actually not probably closing the connection or not closing the session correctly.
Okay, so is that something we can set it up within the SQL Server?
Or Amit, she probably deleted the connection within SSIS.
Is this
no?
question
Sometimes, sorry for interrupt. Sometimes what the same functionality will happen in my client as well. So they will open the sessions and they will click on the refresh buttons on the front end or web server. The connections will be open. Only one connection will be completed. Another connections will be in sleeping state. You have to check the status of the connection by running who is active procedure or sp_who2. If it is sleeping state, we have to kill them, or we have to ask application team rewrite their functionality again.
Sure.
So sorry.
Okay, sure. Thank you.
Yeah, these are application specific scenarios. You see how web server, mobile apps or client applications are talking to SQL Server, how they're utilizing the connection pool, thread pool. So what all of you are actually referring to are all application specific scenarios where applications would establish sessions, connections, would run the job or the workload, but will not correctly close the session, release the thread. So yeah, those things need to be fixed from the application side.
Okay, sure.
But SQL Server can definitely help you to figure a few things out. And of course, here again, we have to use DMVs like sysdm exec session. Every session has a status or a state. So you could see whether it is runnable, running, sleeping. Those are the different statuses that you can figure out. You can also figure out if a specific session has a request. So you have to use the DMV sysdm exec request. Request will have any active requests that are pending, and status for that also will be shown. Then you can further find out if every request has a specific task. There could be one or more tasks. If it is serial thread, there will be a single task. If it is a multi-threaded request, which means parallelism, there will be multiple tasks. So you can also find out that using a DMV called sysdm_os tasks. So all these DMVs that I'm talking about, like connections, sessions, requests, tasks, threads, workers. A combination of all 6 can actually help you identify who is doing what inside SQL Server. Now, the stored procedure that Hanu was talking about, let's say SP who is active or who2, etc., and all of these that are available are actually pulling out information from these DMVs and presenting it to you in more readable format. So SP who is active is a good stored procedure to use. Okay.
If no one asks, can I ask one generic question, Amit?
Yeah, please.
Yeah. can we find out how much memory the query was used using the execution plan? Actually, I searched for the internet. I did not get a proper answer.
So you can only find out how much query specific operation is using inside the execution. Let's say a memory operation, right? And a sorting operation, or for example, a hashing operation, and how much extra memory grant have they used. But trying to find out the overall memory consumption of a query, that question itself or that requirement itself is technically incorrect, because memory is a very shared resource. Look at what's happening when you execute a query. All the different iterators, they need memory. The execution engine needs memory. The parser needs memory. The couple of components in the life cycle that need memory. And then your query is fetching data from the disk, and it's actually reading shared buffer pages, 8K pages. But your query is not the only query that is reading those buffer pages. There are a lot of other queries that are reading the same data in a multi-tenant environment. So you cannot really attribute all of that memory to your query. Now, even if you sum up all of that, even if you find out an algorithm and kind of add up all of that memory and say, my query is using this much memory, the session itself uses memory, and the couple of other clerks that come into picture that consume memory. Trying to figure out and getting a number is going to be very, very approximate and probably could be technically incorrect.
Okay, thank you.
So any algorithm that is trying to show you that your query is using X amount of memory, or this session is using X amount of memory, it's just going to be a very, very vague thing, right?
Okay, yeah, I understand. No, so one of my managers argued with me, we can find out from, execution plan from the memory. I told them like, and each and every operator, it will run from the memory side. So we cannot find out. So that's why I want to check with you. That's it. Thank you for clarification.
Yes, exactly. It's not. And I will turn around the question in another way if all of you are paying attention to this discussion, and it's a good discussion, which is that what is the need? What is the need to find out how much memory is being consumed by your query? It does not really solve anything if you look at the bigger picture. You're trying to, if the requirement is to troubleshoot where the memory is being consumed. Let's say your server is choking with memory, 90%, 95% memory is being consumed. SQL Server's total server memory and target server memory is same, and you're trying to troubleshoot that. Then go and look at clerks, sysdm OS clerks, and find out the memory being used by each clerk. That will give you the real picture of what's happening inside SQL Server.
Yeah, so we can find out the memory pressure, as you told, like in target memory and total memory. Our OS underscore memory is there, and some operations, virtual memory, physical memory is not equal to 0, it's 1. Something is memory pressure, we can find out. Okay, thank you.
Exactly. Right, friends, with this, I'll come to an end of this session. We are bang on time. And yeah, the whole idea was wanted to present the concept, show some demos, and I just wanted to go slow with it so that you grasp that weight types, weight statistics are really the gateway to troubleshooting query performance. There are a lot of other things, as we discussed, that can be done, which is here, but probably weight types and weight stats should be the first thing to do. Okay, friends. So rest, there are a lot of stuff out there. You know the scripts and everything. You can just go to SQLmaestros.com and yeah, download the scripts. You can become a free member at SQLmaestros.com. Just take a note of it, and you can download all the scripts. You can watch a lot of sessions in our video library, a lot of tutorials that may help you. And I would also invite you to let me just see and share the window. Invite you to download the SQL Server Geeks magazine here. That is, if you just go to SQL Server Geeks, this is the new magazine that we have launched, and I'll share the links with Gene. And this is again free for the community. So just go to SQLServerGeeks.com. That's the URL. Hope you can see it. And you can see that there is a magazine there. Subscribe and get your copy. This is the new stuff. We have just launched the May edition. You can click on that, sqlservergeeks.com/magazine, and you can download your free copy. A lot of curated content from Microsoft and from the community here. And we are in next week, we are going to release the June edition. If you look at the table of content, there's a lot of good stuff out there. Yeah. So friends, that's all from me. Over to Gene. And yeah, if you're on Twitter, please do tweet. My Twitter handle is _Bansal.
Thank you, Amit, so much. I appreciate it.
Yeah.
Yeah, thank
That's
you
when
very
I'm on
much.
Twitter.
It was very informative.
Yeah, I used to follow you. Bought the flat also, right? Last 1 year back or something.
What?
Thank you.
Okay. I bought what? I didn't get that.
No, flat, something you have shared the flat photos in Mumbai or some area.
Okay.
Thank you, Amit.
Yeah. Thank you. Thank you for following all of that. Thank you.
Yeah. Thank you very much. Bye.
Excellent.
Thank you, everybody. Have a good day. Thanks, Gene, for the opportunity. It was wonderful presenting today. Thank you so much.
Thank you so much.
Thank you very much.
Thank you, Amit.
Excellent.
Thank you.
Yes.
Goodbye.
Meta,
Thank you.
thank you so much for your presentation. It was an honor to have you here.
Thank you, Jane.
Yes, and then thank you everyone for attending our today's presentation. A version of this presentation is being recorded, so I will share the information with you sometimes later. Amit, I'll be waiting on you to email me all the link, so this way I can share it across when I'm sharing the recorded video. One more time, thanks again, everyone. Bye-bye. Don't forget to register for our next meeting. To our next meeting. Thank you. Bye.
Where on Secret Maestro was the scripts? Is it still on there?
Yes, I have shared this information since last week.
Is the return still on Secret Maestro? No.
Yes. Thank you, guys. Bye. Thanks again, Amit. Thank you. Bye-bye, guys.